So, welcome to my presentation about AMD platform status in coreboot. How many of you know what coreboot is? Okay, so mostly you know what it is. So, just for those who don't know, it is an open source firmware framework that allows to replace the vendor BIOS with own custom firmware implementation. And my name is Michał. I'm a firmware engineer at FreeMD. You can find me on those social medias. Those small icons are a hyperlink, so you can contact me via those medias. And basically, I am a PC Engine's platforms maintainer in coreboot. I also am responsible for Boswell SoC support. And yeah, I have recently become one of the 36 coreboot developers, which are officially privileged to merge patches. And my region of interest is mainly security solutions and advanced hardware features, enablement, analysis, etc. So I would like to talk about about definitions, like some AMD components present on their processors, just to know the terminology I will use during the presentation. And I will briefly describe the history of AMD and coreboot cooperation throughout the recent 10 years or so. And we'll also talk about the current development of newest SoCs and talk about the current status of platform maintainership. So, few terms that you need to know just to keep with me with the presentation and what I will be talking about. So, first term is Adisa. It's AMD generic encapsulated software architecture, which is a bunch of code or a blob, depends, which is responsible for the silicon initialization mainly. There is also a CMAX. It's an older version of soft-bridge initialization code, which was later merged into a GESA, which I will also mention later. FCH, it's a fusion controller hub. So it's kind of a new generation of AMD soft-bridges. It's almost like the same as Intel changed their ICH, IO controller hub, into PCH, which is a platform core hub. So it's like equivalent migration. And PSP, platform security processor. It's an equivalent of Intel ME for on AMD processors. And it's also responsible for some cryptographic operations, security, CPU bring up in some part. And yeah, when it comes to the Adisa, it's also an equivalent to Intel FSP, just to compare. Yeah, and there is very complicated code name and microarchitecture naming, code naming, and yeah, I will not dig too much inside this topic. I will just refer to Wikipedia or something like that. So the beginning of AMD cooperation with coreboot began around 207, 208, where AMD contributed the Adisa code that supported some family 10 processors, some geode processors. So what was this code responsible for? Mainly it was processor memory, the hypertransport initialization. Hypertransport is the interface that links, for example, multiple processor sockets on the mainboard. There was also the soft-bridge initialization, the CMAX, which supported few of these chips I have listed here. There were mainly free chip solutions, like there were CPU, there was some North Bridge, and there was the South Bridge. These are currently not available in the master branch, but if you look at the older tags of coreboot repository, you can find those. They were dropped because they were very hard to maintain. Like, this was pretty old architecture, and so, for example, there were no memory type range registers, and the memory had to be set up through some non-common way. And there was problems with some clean caches RAM setup. Caches RAM is a temporary memory solution on x86 processors. And for example, there was code that initialized, for example, 500 megabytes of memory just temporarily, and later we will fix it. Yeah. So there was a bunch of places like that, and yeah, the community decided to drop this support because it was holding back the whole project. And the example products are, for example, PC Engine's Alex boards. PC Engines is a Switzerland company which produces typically network compliance devices like routers. And for example, this one has a Geode processor, Geode Alex. And yeah, this was also one of the problematic chipsets and processors that I mentioned with, for example, the RAM initialization. Yeah, and later, around 211 till 213, Adisa V9 emerged. It supported family 14H, starting with family 14H, and yet there still was the CMX code base, which was responsible for the soft bridge initialization. But later, for family 15H, the CMX has been merged into Adisa, so just made less burden for the developers to integrate. Because CMX put some kind of requirements, for example, call this function on right after power on, because some soft bridge registers have to be initialized first. Yeah, so it was a problematic, so it has been merged into Adisa. Yeah, and the CMX has been merged into Adisa, and the discrete fusion controller hub has been introduced. So we are basically going out from the free chip solutions, and we have only the CPU and the FCH. And for example, those open source Adisa was introduced for family 15, the Trinity codename. For example, you can have a family 15 support on Lenovo G505 and S, and for example on this Asus boards, and family 16H, which was codenamed Cabini, and some of the main boards also supported, like those ASRock AMD A180. This open source fashion maintained until 214, where AMD introduced closed source Adisa blobs. Yes, and the community was not happy about that, but there is, I think, a rationale behind that, because with the introduction of the binary pi, which is a name for the closed source Adisa binaries, AMD introduced integrated FCH, so first SoCs appeared, and of course the first appearances of PSP also occurred. So they had to close certain things just to not reveal intellectual property, etc. Yes, and binary pi is supported since family 15. Processor models like I have listed here. Yeah, I will not elaborate on these numbers. These are taken from CPU IDs. Yeah, so when you have a CPU ID, the most significant byte was a family number, and later there was the processor model, so it emerged from that. Currently, no Adisa, the old Adisa source, as I have mentioned till now, is not maintained by AMD. They just left the support of those. And yeah, as it is a closed source blob, it causes a lot of problems. Like for these blobs, there is a broken suspend resume support, or we have issues with temporary memory teardown. For some blobs, it was it was fixed, but in close cooperation with gigantic corporations like Google. For example, there is a Stone Ridge SoC, which is a family 15 and processors models from 70, and they got a license to fix that and release a fixed blob for the temporary memory tear down. And yeah, I have listed, as I have listed here, the products you can find with those are now Chromebooks, the Stone Ridge. There are a few Asus or HP Chromebooks you can find out there, still available to buy. Like some recent releases were in the beginning of 2019, I think. And yeah, the most popular product to me is PC Engine APU2. It's very simple router platform shown here, which is family 16H, these processors models, and it has quite some awesome features I would like to also mention. If you have been attending the talk about Range Boot, for example, it describes the DRTM implementation on AMD and Intel processors. So the prototype of the DRTM support was developed on this platform. Yeah. Also, Europe project is very highly depending on validation on this platform. Yeah, so Ron Minich also prototypes many new features also on this platform. And yeah, PC Engines has a very long story with coreboot, it must be said. Their products, yeah, they're over 10 or 15 years in this open source, and coreboot is their only firmware they run on their platform, so it's very respectful. Now it came to the future and the present. Currently there is a work in progress development on Adisa V9. It is another closed source implementation, but with more restrictive license, because it is aimed to support only Chromebooks for now, and there seem to be some mainboards just freshly announced, but currently there is no mainboard in coreboot yet. And it is aimed to support the family 17, which is Ryzen, Zen, etc., these new AMD processors. And yeah, this development is proceeding quite slowly because the way AMD changed the boot flow is quite surprising. How many of you know the x86 boot process? Okay, so typically BIOS is responsible for DRAM initialization. Okay, so AMD just broke this rule and said, no, let's let PSP do the DRAM initialization. So now, when a CPU comes out of reset, it has already DRAM initialized and memory working. Yeah, so it needs a quite significant amount of effort to adapt to the coreboot build system to support that. Yeah, if you want to hear more details about how the Adisa was integrated, I just can. Yeah, I please refer to this presentation of Kerry Brown's talk from OSFC 219. He was talking about the Adisa integration to coreboot using Intel FSP 2.0. What it is about? It basically describes how they adapted the FSP interface, Intel FSP interface, to Adisa. And there is a link with some incoming products on Chromebooks, but to me the current status is unknown, unfortunately. Yeah, a little bit more about the future. Currently, many boards that had some AMD CPUs were being dropped due to new release requirements that coreboot project put on the code. So yeah, AMD platforms lacked support for many years due to AMD left the support of the Adisa. There was very little developers that could even maintain some platforms. So the only hope is in PC Engine's company and other like these companies that just support open source firmware effort. And we were recently struggling to cover as much as possible chipsets to maintain the support. And for example, we fulfilled the recent requirements about C-boot block and postcard stage. You can refer to coreboot documentation what it is about. I will not describe it now. So the development I took with Kioski Malki in the fall last year. We sit for 2 months and was just pushing patches constantly every day just to clean up the code and make those boards still available in the main tree. And there's still much cleanup work to do. There is all the AMD code base were mostly copy-pasted work, so there is very much of dirty code, like some MP tables, IRQ tables are mostly copied, for example, 2 or 3 families in a row, and yeah, the ACPI code is also poor, so it requires some effort to develop some fancy features. And yeah, for now the AMD platforms can move on thanks to my and Kioski's effort, but it is unknown when these platforms will face a wall which cannot be overcome. Like we have to face closed source blobs for certain platforms, and yeah, it makes the work even harder. Besides the Adisa, there were few native ports also, like these boards I have listed here. Unfortunately, they were dropped from tree, despite they were fully open source. They had no blobs. They were only natively ported by coreboot developers. Why they have been dropped? First of all, they have been left unmaintained. Some of their port authors just switched to different architectures. Like, for example, this board KGPE was created by Raptor Engineering, but currently they are switched to PowerPC. And they don't feel like adding more effort to bring this board back to master branch. Secondly, it will require a significant amount of money to bring the port back because of lack of attention for the past few years. And there's many requirements that coreboot put since that time, and there's a lot of work to do. Thirdly, there were many bugs left, which has been unfixed after the initial ports. So it is also required to address that because there were many complaints recently on some Linux crashes, for example, on these boards. And yeah, it's a shame where such a library hardware is dropped from the tree. But there is a hope. Firmware applied for funding to bring back those native ports. And why we did even bother with this? First of all, as I said, it's a library hardware. Secondly, for example, the KGP board has IOMMU and has DRTM capabilities. And in contrary of Intel TXT implementation, the AMD DRTM can be fully open source. So we can have a SRTM, DRTM, fully open source on such platforms. And the future we see for AMD platforms is as follows. Firmware, of course, is planning to improve the AMD support through the cooperation and help from PC Engine's company. Possibly we would like to bring back the other native ports like the ASUS KCDMA or the Supermicro. Of course, if there will be a much common effort with the KGP. And I think the support for Ryzen CPUs is rather far in the future, because there's a lot of work still to land in the current repository, and it's just proceeding slowly because most of the documentation of on the family 17H is not public, so it is hard to gain some expertise to review the patches. Only those who have some NDA with AMD are able to help with the development. And yeah, when it comes to some server platforms for this newest AMD, it is also unlikely. Like I said, it will target mostly Chromebooks in the nearest future, but in the far future, maybe. These are some references to presentations I have based on, so you can also have a look at these to have some insights about the history of coreboot development on AMD, and some of the presentation was also based on my own experience. Any questions? No questions? Oh, please.
Yeah, so my last learning was but I mean, kind of like the way they did it was they stripped as many ME modules as possible, and then any ME modules that would cause instability on the CPU, they kind of just tried to like trim it down. So you were recommending that the PSP for the AMD module might be for moving to a world where ME and PSP cannot be.
So the question was whether the PSP can be stripped down like Intel ME. So recently some patches landed that removed certain blobs for a PSP. Like for example, we left some bootloader only, which is required for CPU bring up, but removed the PSP OS. For example, recently it was about in September or October last year. But for the newest ones, I think it will be pretty hard. So there is no much documentation on the newest PSP, and I'm not in this newest PSP topic that deep, but I can say that it will be pretty hard to strip it down. Any other questions? Okay, thank you.